Hi, everyone. Welcome to the webinar. I got an opportunity to present at SAE World Congress recently, and I thought I'd share those topics with you. Functional safety is a big topic for many people in the automotive industry these days, and I thought I'd present a few topics of how to implement functional safety and specifically some requirements that are slightly onerous. So thanks for joining, and we'll get started. For the topics today, I am going to go through functional safety, but at a very high level, and I'll give an overview. I know many of you have very large documents, so you'd have to spend quite a bit of time going through it. But I think what's important is I'm going to pick a few topics out of it, a few requirements that really force change within an organization, and then I'm going to focus also on a software vertical. In the end, I think you'll see software is the biggest impact on functional safety and vice versa. I mean, you will spend quite a bit of time on software topics as it pertains to functional safety, and then the cost also, I think, and I'll reiterate that a little later, and I'll show you the examples. The cost also really is reflected in the software vertical. So let's jump right into it. So I'm your host, Steve Nima. I've got quite a bit of background with safety critical application, and I think you can read it there, but what makes it most unique, I believe, is that I've seen the implementation in multiple industries. I've seen it both in aerospace and defense and rail and in automotive as well. And now some of those have parallels. Some of them have their own unique constraints. And in automotive, I think somewhat the most difficult given the numbers of permutations of cases for autonomous driving and so on. So safety is something I've been working on, product development, something I've been working on for over 20 years. And safety critical product development is something I've been focused on for quite a long time. And I'll jump right into the functional safety topic. If you look at the main page of the document, it strikes you immediately. There's a V. However, I actually see it as a W, which is interesting. So they give you a V for the hardware section, they give you a V for the software section, and then an overarching V. And when I see this, I think coverage. How are you providing coverage? How are you ensuring that you're testing the right cases and you're providing a safety case? And then that's what the V diagram means to me here. And then overall, though, there are things wrapped around it, like management and supporting processes, which are just as important, actually. So if we jump into, the specific topics, I'm going to go one by one and give you, one requirement out of the sections that has a pretty strong meaning and implication for you. I've lumped three sections together, 2, 3, and 4. And there's one line in the management section which says the organization shall create and foster and sustain a safety culture. That's a very, vague statement. However, the example I can give you is, when in a previous life, when a safety issue occurred in the field and there was human harm, the decision-making across the organization changed. As the head of R&D, I no longer had priority for development projects. The safety issue had priority, and the safety director managed those resources. So it really is about the decision-making that occurs within your organization when a safety issue occurs in the field. And that has a big meaning for a lot of people. I mean, I don't know that necessarily every organization has such a decision-making process, startup companies, et cetera, et cetera. They don't really have that set up right off the bat. However, larger organizations already have that. If you think about a workers' comp situation, there's a person responsible for that if someone gets hurt on the job, and that's an on-the-job injury. And there's an HR and a legal team that handle it to ensure that you comply to the regulations. Well, this is something similar to that, however, more on the engineering side of things than it is on the getting injured at the job situation. And another element I've pulled out is the software architecture or system architecture. And if you read that statement, if an element is comprised of sub-elements, then they're put in the same context, then they take the highest ASIL. What it really tells you is that if you've got safety features, don't combine them with your non-safety features. So the example I can give you is satellite radio and a braking system. You don't want those in the same processor. You don't want those on the same memory map. And if you do put them on the same memory map, then you're going to have to apply functional safety to both of them. So as companies are trying to make cars autonomous, there are companies trying to make autonomous cars. And there's a difference in that, because if you do it from the ground up, you will design an architecture that handles the safety criticality in an efficient manner, rather than trying to slap, a sensor system on an existing vehicle and make the entire thing safe. It really does have an implication to how you architect your systems, and that's why I pulled this particular, element out of the document. If we jump into hardware, the one main focus of hardware and functional safety is the avoidance of single point failures. And if I just use layman's terms, if a single thing fails, it doesn't cause a safety issue, right? And whatever that single thing is, a capacitor, resistor, the radio example, the tire bleed, whatever it is, single point failure does not lead to a violation of a safety goal. That's how the document describes it. And the entire section is really geared around designing hardware that avoids that. And once you've done that, and the mechanism in which you do that is kind of defined in the appendix, and they give you examples here like non-volatile memory checks and block replications, adding sensors, et cetera, and built-in test, which is more of an aerospace term than it is an automotive one. You're really driving software requirements, because once that hardware is actually out there, you're driving software requirements. So hardware avoids single point failures, design an architecture that a software can actually add diagnostics to, and then obviously follow the V diagram model that you see on the page here, which is requirements to test. It's a pretty standard process. Software. So software, quite a large section, very important, like I mentioned earlier, and again, the architecture discussion. If you combine software of different ASILs, of different safety criticalities, they all take the highest safety criticality. Again, a very painful statement. So what do you do about that? Well, design it so that you don't do that. Isolate your safety requirements, architect a system where you can do that, use external means for safety requirements. So there are many, many ways of handling that, but it is a very onerous one-liner. And that is very typical of any guideline. There are lines in there that, if taken as strictly as it's said, impacts almost everything in your system. And then on the right side there, you see that, from a unit testing standpoint for software, they want it tested in a real environment, on target. And they use the word closely, again, a guideline type word rather than a requirement or hard word. And it comes down to, can you validate your safety case? Can you justify what you're doing from a unit test standpoint? If you're only testing in simulation for some parts of it, if you're only testing on hardware for other parts of it, if you're testing at a system level, if you remember I mentioned coverage earlier, and you can make a case of that, then you handle this requirement. But that also implies that you're managing your workflow, and it implies that you're managing your requirements and test cases in a tool chain. So again, like just one line, and all of a sudden we're buying tools, we're managing across the organization, we're talking to the systems team and the software team working together. That's all implications of that one line in the software section. A few more software requirements, some of them buried into the production section, right? So a procedure shall be defined to ensure the correct embedded software is put on your ECU. So just from a standard production process, they want to make sure that whoever's loading the code onto the vehicles or the ECU has got the right version. So it implies you've got a versioning system. It implies you've got a process between engineering and production and a change control board and all those things. But where this becomes very interesting is, what if software is ever changing in the field? So software is downloaded over the air. It has an entirely new meaning now. If you're going to meet this, then you've got to have quite a sophisticated system to be able to do that and still meet the intent of functional safety. And then in the middle here, the test equipment shall be subject to control and monitoring. And I've had this case, in many times in my career. I take a piece of software and I put it on one equipment and it passes and it works phenomenally. And I put a piece of software on another equipment, which is apparently identical, and it failed. And I find out later on that someone had modified something in the test equipment. So, and I think this is what it's getting at. It wants you to control both the versioning and the hardware software application of all the test equipment you have in your organization. Then on the right, the field monitoring process for functional safety incidents shall be planned in accordance to ISO 26262-2. They're pointing straight at the management section. And the reason they're pointing at the management section is because if there's a safety issue in the field, it changes the decision-making process. So it's not the same as an issue which is not safety related. And in your organization, is that a true statement? Or is it still managed by the same people with the same decision-making process with the same priority? So it's pointing at the management section from the production section of how they want field monitoring to be done. And again, that implies tools, implies process, implies training, implies management changes. So some key takeaways, functional safety really is all about software. And I don't mean to demean or belittle any of the other parts. But if I were to put a similar, dollar sign as the Yelp reviews for restaurants, software gets $5 signs for cost. And even worse than that, software V&V gets 5+. So anything you can do to make software verification and validation easier. So that's automation, that's standardization, and that's applying safety, right? At the front end, before this goes to the test team. Anything you can do from that standpoint will save you millions at the back end. And then in the end, the planning for all of this, the organizational planning and the management from the top is really the key to success. And that will define the winners and losers once a regulation comes out that implies that you have to actually implement this. As right now, it's pretty much set by the OEMs and the requirements that come into most RFQs, and it's relatively optional. There is no regulation right now that forces this, but I believe eventually there will be. So thank you very much for attending. I hope this has been helpful, and I hope to hear from you sometime soon.